All right, mathletes, here we are looking at problem solving with systems of equations. So, steps you want to kind of follow here is decide the two unknowns and delegate them variables. Usually we pick x and y, but whatever you want to do. Write down the two equations connecting x and y that you're from the word problem you have. Solve it with a simultaneous equation. You can pick whatever method you want by graphing or substitution or elimination. Step 4, check your solutions with the original data given. Make sure it makes sense. Give your answer in sentence form. Specifically, make sure you talk about units and put it in context of the problem. Okay, so our first example here, we're just going to look at relating two numbers. So we say two numbers have a sum of 45 and a difference of 13. Find the numbers. So after I read it through, I realize we're talking about two numbers. X is, we'll just say number 1, or the first one they're talking about. Y is equal to the second number. Okay, so using the first piece of information, the two numbers have a sum of 45. So I know that sum means addition. So x plus y equals 45. Okay, the second piece of information is that the two numbers, the difference of them is 13. Okay, so if I do subtraction, I do x minus y. Okay, the difference is 13. Okay, find the numbers. So since I have them set up like this, from this given information, I have it set up so I think elimination is going to work best since they're stacked and all my x's and y's are on one side. And it's nice because I have a positive 1y and a negative 1y on the second one. So if I add these up, okay, I'm going to get 2x. My y's will eliminate, and I end up getting 58. Okay, so now I have one equation, one unknown. I can solve for that x. I divide by 2, and I get x is equal to 29. Okay, now I can backwards solve and put it back into either one of the two equations. I'm just going to put it back into the green one. So then I'm going to get 29. Substitute in my x minus y is equal to 13. Okay. Subtract 29 from both sides. I'm going to get negative y is equal to negative 16. Okay. And multiply each side by a negative value, so I get y is equal to 16. Okay. Now I can say that my two numbers, so put it in the context of the problem. My two numbers that sum to 45 and have a difference of 13 are 29 and 16. Okay, so there's our first example. Since our unit's dealing with money, our second problem and third problem will deal with money. Okay, so when shopping in Jamaica, 5 coconuts and 14 bananas cost $8.70, and 8 coconuts and 9 bananas cost $9.90. Find the cost of each coconut and each banana. So after I read it through, I'm going to delegate my variables. Usually it's pretty straightforward if you look at what the question is asking you. Since I'm looking for cost of coconut and bananas, well, I'm going to let x equal the cost of coconuts. And oddly enough, in Jamaica, we're using dollars. Okay. And then y, we are going to say the cost of bananas in dollars. Okay. So then look at my first piece of information, that 5 coconuts and 14 bananas cost $8.70. So to get the cost of my coconuts is going to be 5 times the cost, which is 8. Okay. Then I'm going to add it to the cost of the bananas. Well, I had 14 bananas, so I do 14 times y equals the total cost, which is $8.70. Okay. My second bit of information is 8 coconuts and 9 bananas, costs $9.90. Right? So I have 8 coconuts, it's 8x, plus 9 bananas, 9y, equals $9.90. Okay. So now that I have these set up, again, I have both my x's and y's on one side, so I need to solve my system here. And because I have them both on one side, I find it easiest to do elimination. So I don't have any negative values here, so I'm going to have to try and get a negative. And I don't have any common factors here with 5 and 8 and 14 and 9, so I'm going to have to multiply both of them. So I'm going to multiply the top one by -8. Okay, so the opposite of what this one is. Okay, and I'm going to multiply the bottom equation by 5, which is this value. So that I'm trying to aim to get 40 and -40 there so that they eliminate. So after I multiply this equation out by -8 every single term, I'm going to get -40 x times -112, and then 8.7 times -8 using my calculator, I'm going to get equals -69.6. Okay, doing the same thing with multiplying by 5, I'm going to get 40x plus 45y equals 5 times 990 is 49.5. Okay, now since I have them up, add them up and eliminate. My x's are going to eliminate, so those go to 0, and I have 112 minus 45, or -12 plus 45, and I'm going to get -67. Y equals, so -69.6 plus 49.5, and I get -20.1. Okay, divide both sides by -67, divided by -67. And I'm going to get that y is equal to 30 cents, or 3/10 of a dollar. Okay, now that I have y, I can backwards solve. So let's just say I plug it back into my first equation. Okay, so I'm going to have 5x plus 14 times 30 cents equals 870. So I now know that 14 times my 30 cents is going to be 420 equals 870. Then I can subtract that 420 from both sides, and I can see that the cost of my coconuts alone was $4.50. Dividing by 5, I'm going to get x is equal to 90 cents. Okay, so in the context of my problem, I'm going to write that cost of a banana is $0.3, and cost of a coconut is 90 cents. Okay, last example here. So here we have only 5 cents and 10-cent coins in my pocket. I have 24 coins altogether. Their total value is $1.55. How many of each type of coin do I have? Okay, so I've read through the problem. Now I'm going to delegate my variables. Okay, so let's say x is equal to, so how many of each type of coin? So this is the number of coins what kind of types of coins do I have? Number of 5-cent coins. Okay. Y is going to be the number of 10-cent coins. Okay. So, first piece of information, I have 24 coins altogether. So I know that X plus Y equals 25. Okay. And their total value is $1.55. So, number of 5-cent pieces. So X times 0.05 will be the value for my nickels, my 5-cent pieces, plus the value I would get for my 10-cent pieces is Y times 0.10. Okay, and this is equal to the total value, 1.55. Okay. At this point, we'll just change it up. I'm going to, because I have these decimals, I'm kind of wanting to use substitution here. So I'm going to rewrite this one in terms, get Y as a subject, so I get Y is equal to 25 minus X. Okay. From there, I'm going to substitute that in to my second equation. So I have 0.05 X plus, well, my Y is 25 minus X times 0.10 equals 1.55. Now I have an equation with only X's, so I should be able to solve. So I'm going to distribute across. So I'm going to get plus 25 times 0.1 is 2.5 minus 0.1x equals 1.55, and then this just drops down. Collect my like terms on the other side, on the left side. So I have negative 0.1x plus 0.05x is going to be negative 0.05x, and then subtract 2.5 to both sides. And I'm going to get is equal to negative 0.95. Divide by negative 0.05 on this side to get x by itself. Divide by negative 0.05 on this side. And I get x is equal to 19. Okay, since x is equal to 19, I'm going to plug that back into my first equation as I find that's easier to work with. So I'm going to get x, which is 19, plus y is equal to 25. Subtract 19 from both sides, and I get y is equal to 6. So, putting in the context of the problem, I know that I have x, so I have 19 5-cent coins, and I have 6 10-cent coins. Alright, mathletes, that concludes our notes for tonight. Please highlight any questions you may have and bring them to class tomorrow.